This video is the second part of section 3-5, where we're going to solve word problems using systems of equations. I've selected 4 random problems as examples. As you're taking notes, think about how we're taking the sentences from each problem and creating an algebraic system from it. Once we've created the system, we'll use linear combination or substitution method to solve. Here's the first example. A boat can travel 6 miles downstream in 40 minutes. The return trip requires an hour. Find the rate of the boat in still water and the rate of the water current. So there are 2 unknown things we're asked for, and that's why this problem takes 2 variables. First step, we're going to define the variables. We can use any letters of the alphabet we want, but it's common to choose X and Y. We want to explain what we're letting the X represent and what we're letting the Y represent. So the letter X will be our first unknown, the speed of the boat in still water. How fast is the boat going simply due to its own engine? The variable Y will be our other unknown, the rate of the water current. How fast is the water flowing? Step 2 is to create an equation. Step 2 is to create a system of equations using the information from the paragraph. The first sentence tells us the boat can travel 6 miles downstream in 40 minutes. The second sentence tells us that that same 6-mile trip requires 1 hour. The first sentence is measuring time in minutes, while the second sentence is measuring time in hours. Let's make a conversion so we're using the same unit of time. 40 minutes is the same as 40/60ths of an hour, which reduces to 2/3. 40 minutes is the same thing as 2/3 of an hour. Next, remember the formula distance equals rate times time? We will use that to help us make our system. The overall speed of the boat when it's traveling downstream is equal to the speed of the boat in still water plus the rate of the water current. That can be written as X plus Y. Then let's multiply by T to find distance. The time that the boat is moving downstream is 2/3 of an hour. And when we multiply the speed by that time, we get distance, which is 6 miles. Here's the first equation in our system. Now let's make an equation from the second sentence. The return trip when the boat is moving against the current takes an hour. The overall speed of the boat when it's moving against the current is equal to the speed of the boat in still water minus the rate of the current. Now let's multiply by time to equal the distance of 6 miles. The time is 1 hour. Here are 2 equations that have X and Y written as a system. Let's rewrite the first equation so it doesn't have a fraction. We can do that by multiplying both sides by 3/2. When you multiply the left side by 3/2, it will cancel the fraction, leaving X plus Y. When you multiply 6 by 3/2, that will make 9. In the second equation, X minus Y times 1 just makes X minus Y, and that's equal to 6. This system is equivalent to this system, but the equations look much nicer. Now let's solve the system using linear combination or substitution. I'm going to choose linear combination because the Y terms are already opposites of each other. We can combine the 2 equations together. X plus X is 2X equals 15. Dividing by 2, we get X equals 15 over 2, or 7.5. We have figured out the rate of the boat in still water. Now we need to get an answer for y to find the speed of the current. Because we know the answer for x is 7.5, we can substitute it in place of x in the first equation. 7.5 plus y equals 9. Then subtract 7.5 from both sides to get 1.5. Because this is a word problem, we're not going to write our answer as an ordered pair, 7.5 comma 1.5, because that doesn't have much meaning in the context of the problem. Let's explain our answer better than that. We figured out that the rate of the boat in still water is 7.5 miles per hour. And we figured out that the rate of the water current is 1.5 miles per hour. Notice that by taking the time to explain what the variables were in step 1, it makes it faster to record our answers and know what they mean. Let's try another example. Two angles are complementary. That means they add up to 90 degrees. The measure of the first angle is 2 degrees less than 3 times the measure of the other. How large are the angles? We need to find the measure of two angles. That's why there will be two variables. Step 1 is to explain what the variables are. Let's use x and y again. X is the measure of the first angle, and y is the measure of the second angle. In step 2, let's create a system of equations using the sentences from the paragraph. The first sentence tells us the angles are complementary. What is that telling you about x and y? It tells you that if you add them together, it will equal 90 degrees. The second sentence says the measure of the first angle is. What symbol represents first angle? It's x. What symbol represents the word is? It's the equal symbol. Let's read a little farther. 2 degrees less than 3 times the measure of the other. That's 3y minus 2. This system has two equations. Now let's solve it. I'm going to choose substitution method because the second equation already has the letter x alone in terms of y. Substitute 3y minus 2 in place of the x in the first equation. Now combine like terms. 3y plus y is 4y. Now add 2 to both sides. And divide by 4. Y equals 23. We have figured out that the measure of the second angle is 23 degrees. Now let's solve for x. When you look at everything that's been written, do you have an equation anywhere that has the letter x alone in terms of y? We do. It's this one here. That is the best place to substitute in 23 for y. So x equals 3 times 23 minus 2. 3 times 23 is 69, minus 2 is 67. So the first angle is 67 degrees. Let's try another example. A glass manufacturer makes 2 types of glass which differ in silica content. The company has a total of 1,800 pounds of silica to use and uses 216 more pounds for one type versus the other. How many pounds of silica are used for making each type of glass? How many pounds are in the first type of glass and how many pounds in the second type? That's why there are two variables. So step 1, let's define the variables. X is the number of pounds in type number 1. How many pounds of silica are in the first type of glass? The letter Y will be the number of pounds in type 2. Step 2, let's create a system of equations from the sentences in the problem. The company has 1,800 pounds of silica. What equation can you write that uses x and y? X plus y equals 1,800. If there are 1,800 total pounds of silica, and some of it is X and some of it is Y, we add those together and it will be 1,800. Next, we're told that one type uses 216 more than the other. One type, maybe it's the X, uses 216 more than the other. How can you show that in symbols? Y plus 216. In step 3, we'll solve the system. Again, substitution is the fastest way because one of the variables is already alone. In place of the letter X in the first equation, substitute Y plus 216. Now combine like terms. Y plus Y is 2Y. Subtract 216 from both sides. Then divide by 2. The value of Y is 792. So up here in step 1, where we explain what our variables were, the easiest thing to do is say equals 792 pounds. Now we need to find the number of pounds in type 1. We had selected the letter X for that. Do you have an equation anywhere that has the letter X alone? We do. It's this one here. So this is the best place to substitute 792. X equals 792 plus 216. X equals 1008. So the number of pounds of silica in the first type of glass is 1008 pounds. Please notice the three-step process every time. Step 1, define what the variables mean. Step 2, create a system of two equations from the sentences in the paragraph. Step 3, solve the system. And if there's a step 4, it's writing the solutions in a way that makes sense for the problem you're answering. One final example. A jewelry manufacturer needs to produce 2 kilograms of 18-karat gold. By melting together 24-karat gold, which is 100% pure gold, and 12-karat gold. What 12-karat gold is a mixture of gold and silver. 12 carats out of the maximum of 24 carats is the fraction 1/2, meaning it's half gold and half silver. How much of each component is needed? The jeweler is making the 18-karat gold by mixing 2 kinds of gold. That's why there need to be 2 variables, X and Y. X is the amount of 24-karat gold, and Y is the amount of 12-karat gold. Step 2, let's create a system of equations. We're told the jewelry manufacturer needs 2 kilograms of 18-karat gold. What that's telling us is when we add together the 24-karat gold and the 12-karat gold, it must sum to 2 kilograms. The other information we know is the percent of gold in each type of gold. The letter X is 24-karat gold, which is 100% gold. The number 100% as a decimal is 1. So 1 times X means 100% of component X is gold. Plus, the letter Y is representing 12-karat gold. 12 out of 24 is the same as the fraction 1/2, or 50%, or the decimal 0.5. The expression 0.5y tells us 50% of that component is actually gold. Equals, what the manufacturer is creating is 18-karat gold. What percent is 18-karat gold? That's the fraction 18 out of 24, which as a decimal is 0.75, 75%. When we mix these 2 components together, we create a type of gold that is 75% gold. The rest is silver. And we have created 2 kilograms of that gold. The first equation is about the mass of the components equaling the total mass of 2 kilograms. The second equation is about the percent of gold in the different components being equal to the percent of gold in our 2 kilogram mixture. Because the second equation has decimals, let's take the time to rewrite it so it looks a little nicer. Keep the first equation the same and multiply every term by 2. This becomes 2x plus 1y equals 0.75 times 2 is 1.5, and then when you times by 2 again, you get 3. This looks nicer than the one with the decimals. The final thing to do is solve this system to answer the question. I'm going to pause the video for you to solve the system. Okay, here's the answer. It doesn't matter if you used linear combination or substitution to get the answer. I'm going to show the answer using linear combination. I want the y terms to be opposites of each other, so I'm going to multiply the first equation by -1. That makes -x minus y equals -2. And I'm going to keep the second equation the same. Then I'm going to combine them by adding. This becomes x equals 1. Now that I know the answer for x, I'm going to substitute it into the first equation here, 1 plus y equals 2, to find out that y is equal to 1. So the amount of 24 karat gold needed is 1 kilogram, and the amount of 12 karat gold needed is 1 kilogram. Congratulations to you if you got that problem correct. Let's summarize the lesson. We worked on a few sample word problems where you have to create a system of equations using x and y. You create that system using the sentences in the word problem paragraph.